So here we are on page 3 of chi-squared. So number 6, Nandan wants to know whether or not the number of hours spent on social media had an influence on average GPA. He collected the following information. Okay, so once again, be careful. They do have totals here, so these are not to be input into the calculator. We're only going to input the data, right? So I have input the data into matrix A, as you can see on the left. And now I'm going to do the chi-squared test. Oh, before I do that, why don't I say what the null hypothesis and the alternative hypothesis are? So the null hypothesis is GPA and hours spent on social media are independent. And the alternative hypothesis, of course, are GPA and hours of social media are not independent. Okay? Show that the expected frequency for 0 to 9 hours and a high GPA is 31.2. So 0 to 9 hours and high GPA, so that would be 85 over 270 times 99 over 270 times 270. Okay, so we need to show that, so we need to write down this calculation. So we have 85 over 270 times 99 over 270 times 270. Let's calculate that. So we're going to have math, number, n over d, and we're going to put 85 and times 99 times 270. And we're going to put 270 times 270 in the bottom. And then we convert this result into a decimal. Math decimal. And the result is 31.2, which is what they said it would be. Okay, so we did demonstrate that. Write down the number of degrees of freedom. Remember that the degrees of freedom would be the, if it's a 3 by 3 matrix, it would be the 2 by 2 matrix that's interior. So basically it's 4. Okay. So it would be 3 minus 1 times 3 minus 1 equals 4. Write down the chi-squared statistics and the p-value for this data. So how do we do that? We're going to go to stat, calc, start test, and then we go to the chi-squared option, and the observed, of course, is A because that's where we put the data, and we have the chi-squared value is 78.5, and the p-value is 3.59 times 10 to the 16th. 3.59 times 10 to the negative 16th. And the degrees of freedom is 4. The critical value is 7.779. Okay, so let's find out if we reject the null hypothesis or not. We know that the chi-squared value is, in this case, greater than the critical value, and the way we show that is that 78.5 is greater than 7.779, right? So we reject the null hypothesis. We could also do it by p-value. So the p-value is smaller than the significance level, which is 10%. So we also reject the null hypothesis in this case because when p-value is smaller than the significance level, then we reject. So we have 3.59 times 10 to the negative 16th, which is awfully small, and that is, of course, less than 0.10. Okay, so we reject the null hypothesis, and that is why we reject the null hypothesis. So that's it for that one. Let's go down to number 7. Hubert wanted to find out whether the number of people walking their dog was related to the time of day. He kept a record covering 120 days, and the results are shown in the following table. So here we have the different number of people on the left side, and we have the time of day on the over the top, and these are the totals, so this isn't part of our data. So it says test at the 5% significance level whether there is a connection between time of day and the number of people walking their dog. The critical value for this test is 9.488. So in this particular case, they're not really asking us for degrees of freedom or expected frequency or anything like that. They're just asking us to do the chi-squared test, basically. It says do a test whether there's a connection between time of day and the number of people walking their dog. Now, one thing that you do need to do is you need to define the null hypothesis, because when you do the chi-squared test, you are proving that you accept or reject the null hypothesis. If you never say what the null hypothesis is, then it's pretty hard to reject it, right? So the null hypothesis would be a number of people walking the dog, number of people walking dog is and time of day is independent. Okay, so that's the null hypothesis. Let's see if we reject it or accept it. The way we're going to do that is we're going to use a calculator to calculate the chi-squared value. A second matrix, and this is a 3 by 3 matrix, so we're just going to go into edit A, 3 by 3, and then we're going to fill in the matrix with this data. I'll do that offline. Hold on a second. Just put in my data into matrix A, so now we go into stat tests, chi-squared test, and we put A, B in for observed and expected, or that's actually what's already there. And we run the chi-squared test, and we have a chi-squared value of 5.30, and the chi-squared value is less than the critical value because the critical value is 9.488, so we accept the null hypothesis. Okay? Let's go to the last one. That one was just to get you used to different ways of asking for you to do the chi-squared test. So Carl has a part-time job working at a corner shop. He decides to see whether there's a connection between temperature and the number of bottles of water sold. His observations are in the table below. So basically we have the number of bottles of water sold across the side, and we have the temperature across the top, and the totals are here and here. Test at the 1% significance level whether there is a connection between temperature and the number of bottles of water sold. So we could say that the null hypothesis is temperature and number of bottles of water sold are independent, right? And then does it ask us for the alternative hypothesis? Yes, it is. Alternative hypothesis H1. So you just say the same thing, except temperature and number of bottles of water sold are not independent. Okay. Moving on to the next one, write down the number of degrees of freedom. So the number of degrees of freedom, obviously it's 4, because we have a 3 by 3 matrix, and the way we calculate degrees of freedom is we do 3 minus 1 times 3 minus 1 equals 4. So that's the answer for that. And then we write down the chi-squared statistic and the p-value for this data. Did we even fill in the matrix here? And we go into edit matrix A, And we check, oh, we haven't done it yet. So we're going to fill in this data here, and then we can answer this question. So bear with me here while I do this offline in matrix A, and now I'm going to do stat tests chi-squared. And I know that you don't want to do this so many times, but now you've finally gotten to the point where you definitely memorized it for the rest of your life, right? So the chi-squared value is 3.30. So the chi-squared value is 3.30. And the p-value is 0.509. Okay? And degrees of freedom, it shows us is 4, like we calculated. If it ever asks you to demonstrate finding the degrees of freedom, you know how to do that, right? You could just write 3 minus 1 times 3 minus 1. Or you could explain it in a sentence or something. The critical value is 13.277. So now what we're going to do is we're going to take the chi-squared value, which is equal to 3.30, and then the critical value is 13.277, and then I'm going to put that the chi-squared value, which is 3.30, is less than 13.277, which is the critical value. So the chi-squared value is less than the critical value. So I am going to accept the null hypothesis. And then I'm also going to look at the p-value. So the p-value says that the p-value is let's see, greater than the significance level. So the p-value, which is 0.509, is greater than the significance level of 0.01. So that is also means we accept the null hypothesis, because p-value works kind of the opposite as the chi-squared, so that when the chi-squared is small, we accept the null hypothesis. When the p-value is larger, then we accept the null hypothesis. It's just that the p-value, you use the significance level as a threshold, and for chi-squared, you use the critical value as a threshold. So we're not sure on the exam if they're going to ask us to use p-value or chi-squared, so we need to know how to use both.